In our last video, we talked about the definition of derivative, defining the derivative as a function. So f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. And of course, this is motivated from the idea that if I take a line that looks like that, a line that goes through the point x comma f of x, and x plus h comma f of x plus h, I'll get a secant line, and if I let h tend to 0, then the distance between these 2 points gets smaller and smaller until I get a line that just touches at that one spot near x. And of course, defining it as a function, I can imagine putting that x wherever I wanted. In this video, I'd like to show you an alternate definition of derivative and use it to do an example. The alternate definition of derivative. All right, so if I have a function f, I can calculate the derivative just a little bit differently. And this is going to be focused on, instead of thinking about this as x plus h, calling it z, right? And so instead of an x plus h here, then I would have a z. And still thinking about slope of a secant line to start off with. So there'll still be a limit to deal with. And right now I'm going to write h goes to 0 because that's what that says. We might rethink that in a minute. All right. Well, let's see. That would be f of z minus f of x all over. And then this would be z minus x. All right. And the whole idea is what used to be called x plus h is now being called z, right? And so on the bottom here, if I just rearrange this a little bit, I would see that, right, h is z minus x, and that feels good. And this limit says h is going to 0, but h isn't in this expression anymore. Well, if I look here, if h goes to 0, then z becomes arbitrarily close to x. So I could rewrite that as simply saying z has to go towards x. Okay, well, if the distance between z and x gets smaller, it literally means z is getting closer to x. So anytime I wanted to calculate a derivative using the definition, I could use either one. So let's do an example. G of x is the square root of x. G prime of x is the limit as z approaches x of g of z, which would just be the square root of z, minus g of x all over z minus x. All right, I want to do this problem two different ways using the alternate definition because there's always more than one way to do these. But I think the first thing you might have thought of when you looked at it was to multiply the top and bottom by the conjugate. It's a good idea if you see a bunch of square roots. All right, so I have a limit as z is going towards x, z is going towards x, and multiplying this together, I'm not going to distribute, I'm just going to leave it alone. Because if I look here, if z is getting close to x, I'm dividing by 0. My goal is to cancel that off, I hope. And now on top, multiplying by the conjugate, the outside and the inside terms cancel. Root z times root z is z. Root x times root x is x. And hey, I get to cancel off the z minus x. So this is the limit as z approaches x of 1 over root z plus root x. I'm not dividing by 0 anymore. I can evaluate this limit. Z is getting closer and closer to being x, which means this becomes 1 over root x plus root x, or 1 over 2 times the square root of x. We just found the derivative of the square root of x. All right, so that's a perfectly valid way to do it. You can also do this using the original definition of derivative. I want to show you another way to go about doing this particular problem. All right, so g prime of x is the limit as h approaches 0 of, and we had root z minus root x all over z minus x. Instead of multiplying by the conjugate, this time I'm just going to do a little bit of an algebra trick. See, that z minus x doesn't look like the difference of squares, but since I'm dealing with a square root, I'm going to pretend it is. And I'm going to use this old factoring trick to help me out. So, if I'm thinking of that as a square, then it's square root, it's root z. If I'm allowed to use square roots, I can treat any difference as the difference of squares. And now I can cancel that out. Oh, and I wrote h goes to 0 there, and that was supposed to say z goes to x. Well, sometimes when I make a mistake, I reshoot the video, but I'm okay with this so far, so I'm going to keep going. And we all make mistakes, and it's perfectly okay. So z goes towards x, I end up with, well, 1 over root x plus root x is 1 over 2 root x. Same thing I got before. All right, so that is the alternate definition of the derivative.